To work out the size of the centripetal acceleration, we have to look at the change in direction of the velocity of the marble during a very short time, delta t. If we look at the marble again, we can see that it takes delta t seconds for the marble to get from point A to point B. In that time, the velocity changes from v1 to v2, and the marble moves through an angle of theta degrees. If we simplify this diagram and then we add velocity vectors together, we can find that the resultant velocity, delta v. The resultant velocity, delta v, equals v2 plus the negative of v1, which is the same as v times theta. So, to find the acceleration a, we need to calculate the rate of change of the velocity. So a equals delta v divided by delta t. We know that delta v equals v times delta theta, so we can say that the acceleration a equals v delta theta divided by delta t. We also know that delta theta divided by delta t is the angular velocity omega. So we can now say that a equals v times omega. But from before, we know that v equals r omega. So putting this into the equation gives us a equals r omega squared. Or alternatively, we can get rid of the omega from the formula again from before, omega equals v over r. So substituting this into the equation now gives us a equals v squared over r. So we can find the acceleration for the marble using either of these equations. Right, so now it's time for you to test your understanding of this lot by trying the questions on the next slide. If you're unsure, then feel free to repeat this slide before moving on.